Nah. I'm just kidding. Right, okay. Homeostasis, control of homeostasis. Right, imagine there's a change, right? There are two ways that your body could respond to that change. What could those two things be? What am I referring to? What are those two things? So there's a change in the environment, and eventually you coordinate a response. What are the two potential groups of tissue that could bring about that response? What are the two groups of or parts of your body that could bring about that response? I don't know how to give a hint. So the skin, the eyes, and the nose, these things are receptors. They take information in. So I'm talking about effectors. What are the two types of effectors in the human body? So one is a fast response, one is a slow response. Fantastic. What releases hormones, Ardion? There you go. So glands and muscles, right? Glands and muscles. That's it. Exactly. Control of homeostasis. Let's go. So maintaining control conditions within the body is under involuntary or automatic responses. So let me ask you guys a question, yeah? When you are in, I don't know, let's say potential danger, do you tell your heart, start beating faster, bro? We're going to need to lock in. You don't do that, right? So it's automatic, it's involuntary, right? It's involuntary. So when you eat something super sugary, is your body now going to have to respond to that? So you eat something super sugary, is your body going to have to now respond to that? Of course, because if you don't respond to that, what will you have a bunch of floating around in your blood? If you don't respond to it, what will you have a bunch of floating around in your blood, which is unhealthy for you? A bunch of glucose, a bunch of sugar, right? So do you see? So you're gonna have an involuntary response to that high blood sugar. Okay. Does anyone know what it is while we're on the topic of it? You may have learnt it many times in the past. So you may have, you don't eat something sugary and then immediately get diabetes. That's just that's too harsh. I'm talking about like what's the healthy response? Imagine like a healthy person who hasn't got diabetes eats like a bunch of cake. What is that person going to do now to bring their sugar level back down? Correct. Thank you, Nathan. And the right terms as well. Well done, guys. Well done, Manuel. Well done. Anyone who said insulin, by the way, or something to do with insulin, if you produce insulin, you'll break down that extra sugar, right? So that was what I was referring to. But if you're thirsty, yes, your brain will tell you drink some water. If you're low on water, your water levels are low. Maintaining and controlling conditions. Okay, this means that the brain stem, or the non-conscious part of the brain and the spinal cord, are involved in maintaining homeostasis. So is your brain involved bringing your blood sugar down? Absolutely. You don't consciously maintain your body temperature or blood glucose level. This is not a conscious thing. Let's do that, yes. So the brain stem are involved in maintaining homeostasis. So therefore, you don't consciously maintain your body temperature or glucose. Okay, these are automatic controls and may involve nervous responses or chemical responses. What are they? All control systems include cells called receptors, which detect stimuli. Coordination centers, so this could be your brain, your spinal cord, your pancreas, that receive and process information. And then you have got effectors, so muscles and glands. So if it was blood sugar, it's probably going to be a glandular response, right? Could a voluntary muscular response help you with high blood sugar? I'm glad you changed your answer. If you eat something unhealthy and you're like, you know what, I'm gonna go for a run now because I need to burn this off. You're gonna bring your blood sugar down to you're gonna kind of force your blood sugar down because you're gonna use it up, right? Awesome. We're not saying you had a meal. You're like, let's say you had like, I don't know, something super sweet. It might even just be a bit of, I don't know, a sugary sweet, basically. Let it digest first. Okay. Well, it's got to digest first before you get the sugar in your blood, though, right? If you're feeling hyper, that means it's already kicked off. Okay, let's get into it. So when we're talking about glands, when we're talking about hormones, what system are we referring to? So we're talking about gas exchange. We're referring to the respiratory system. When we're talking about blood, we're talking about the cardiovascular system. We're talking about neurons. We're talking about the nervous system. So what are we talking about when we talk about hormones and all that stuff? Chemicals, chemical imbalances. Begins with an E. Thank you, guys. Anyone know? Thank you, Adra. Thank you, Sia. Thank you, Yasma. It's okay. We're gonna find you, bro. It's the endocrine system. Begins with an E. Yeah. Endocrine system. Correct. So endocrine system structure and function. The human endocrine system is composed of glands which secrete chemicals called hormones. You actually definitely need to know that. And obviously they travel in the blood. The blood carries the hormone around the body, and when it reaches a target cell, it produces an effect. So the gland is the effector. And then how does it travel? How do hormones travel? They travel in the blood and they'll get to the target organ. So let's say, yeah, you see some food, right? You're super hungry and you see some food. Your eyes pick up some information. Your nose pick up some information. So your eyes see the food. Your nose smells the food. Hi there, Zeus. You smell food, right? So now the receptors in your eye, right? Actually, wow, their work ethic, man. So your eyes receive some information, right? Okay. Your nose picks up some information, right? And now enzymes are being released, right? Enzymes are being released. Name an organ or name a part of you that would change as a result of seeing some food that you are interested in. So the target would be your mouth, right? The salivary glands, and then that would be your mouth, yeah? So then your mouth is almost like you're salivating. You're producing saliva because you're about to eat. Okay, so that's an example. That's a kind of a quick example there. The blood carries the hormone around the body, and when it reaches the target, it produces an effect. So compared to the nervous system, the effects of hormones are slower, which we learned about already. Important changes are. Now, do not write these because we're going to go into these right now. We're going to go into them in detail. So you don't need to write those down. Everyone got the first green statement written down? Guys, how do hormones get around the body? I want everyone to answer the question. How do hormones get around the body? Sorry, Nathan. Should have known, bro. How did it get around the body? Fantastic. Would you say hormones are soluble? They got to be, right? They're traveling in the blood. No? Don't things need to be soluble to travel in the blood? Okay, let's go. No, not really. Maybe you're right. Homework task. Find out. Right, okay. So I know nutrients have to be like travel in the blood, they gotta be soluble. Go on, find out. Put us out of our misery. Okay, let's go. Yo, Nathan, that's quite some philosophy there. Let's go. Okay, so we got some different sort of glands that you need to know all of them, right? You need to know all of them. So let's talk about the pituitary gland, the master gland, situated at the base of the brain. You actually need to know all of this. You actually need to know all of this. So just knowing where the glands are is quite important. Yeah, this is only combined. This is only combined higher. So pituitary gland, this is the master gland. Yo, so I was right though, right, Chris? I was right. Okay. Yeah, you just few. Oh, I just read that wrong. Few hormones are dissolved in the blood. My bad. Right. Okay. So pituitary blood, the master gland situated at the base of the brain. Now, you will get pictures of the brain, and you'd have to label it and find out where the pituitary gland is. So do remember, it's at the base of the brain. The master gland, situated at the base of the brain. Yes, that's right, Tarek. Then you got the thyroid gland. And as you can see, the thyroid gland is really, really similarly named with the hormone that it releases. Thyroid releases thyroxine. Adrenal glands release adrenaline. So when you are facing an op and they're about to engage in warfare with you, then the adrenal glands go to work, okay, and they release a bunch of adrenaline. Pancreas releases insulin. Probably that's the only one that doesn't really. I know. The nomenclature is top tier. Testes. Okay, the testes produce testosterone. The ovaries produce estrogen. Just a quick one. Just actually no, we'll go through that when we get there. But the pancreas produces hormones to regulate blood glucose level, as well as digestive enzymes such as pancreatic amylase, lipase. Where do these enzymes go though? No, Nathan, it's coming up. It's coming up. Where do those enzymes go? What organ do they go to? Fantastic. They go to the they'll go to the small intestine. Okay, so everyone okay with that? I'm looking for a bunch of thyroxine. Where shall I get them from? Oh, I was basically just saying that so amylase, lipase, protease is released into the small intestine, so it can break down food groups. So yeah, it is located in the throat, so it will be the thyroid gland. Yes. And what controls the thyroid gland? It's the pituitary gland, right? Fantastic. Let's talk about the pituitary gland in a bit more detail. Guys, you're getting chased down the road. Which gland is going to work? You're getting chased down the road. Which gland is going to work? Everyone, please. Zion, you might not be wrong, you know. Ben as well, you might not be wrong. So for those who said pituitary gland, I guess you're kind of right, but I'm trying to be direct, being specific. It's the adrenal gland. It's the adrenal gland. Right? Okay, so okay. Okay. So yeah, I guess you guys are right on that sense. Okay, so the one at the base of the brain, correct. The pituitary gland is in the brain is a master gland which secretes several hormones into the blood in response to body conditions. These hormones in turn act on other glands to stimulate other hormones to be released to bring about effect. For example, in certain conditions, the pituitary gland makes and secretes thyroid stimulating hormone, TSH. So the TSH tells the thyroid to produce thyroxine. So do you see why they describe the pituitary gland as the master gland? Because it tells the other glands to release something. Okay, So just an example there. So let's have a quick look at the structure. Yes, like exactly, it's like the big boss, correct. What I would like you to write down from here is the fact that it is the master gland, but it also, so in why, because let me just highlight it actually. These hormones turn on, act on other glands to stimulate the other hormones to be released to bring about effect. So these hormones in turn act on other glands to stimulate other hormones to be released. And then, or you could just write this example. So we're looking at the pituitary gland right here. So let's have a quick look. So we got the pancreatic gland cells. Sorry, not pituitary gland. We're looking at the bloodstream. Let's have a look at the bloodstream. So here you have the pancreas, the liver. Okay. Here you have the bloodstream, pancreatic guard cells, capillary, and these cells these cells make and secrete hormones. Non-target cells do have a receptor for this particular hormone. So basically the story sort of starts here. Okay, and then you can see that the hormones are traveling in the blood. They're traveling in the blood, and therefore you have these receptor cells picking up that information. So essentially, if those non-target cells pick up or sense the hormone, they'll bring about a change. Let's move on, people. You didn't need to write that example down. Okay. Guys, TSH, thyroid or pituitary gland? TSH, thyroid or pituitary gland? So basically, the pituitary gland will release TSH. The TSH tells the thyroid to release thyroxine. Make sense? So it's actually the pituitary gland that releases TSH. So what's the first effector? Can you see how the pituitary gland is the first effector? Awesome. Guys, let me know if we're on the same page. I hope we are. Blood glucose concentration is monitored and controlled by the pancreas. If you didn't know this, please write this down. However, I feel that a lot of you probably do know this. The pancreas is an endocrine gland making and secreting hormones into the bloodstream, and it also plays a vital role in digestion, making and secreting enzymes for digestion. So that is pretty much given. I think you guys are quite familiar with that. Blood glucose concentration must be kept within a narrow range. So it's another example of homeostasis. It needs to be controlled. So blood glucose needs to be kept within a narrow range. Eating foods containing carbohydrate results in an increase in glucose into the bloodstream. So if the blood glucose concentration is too high, the pancreas produces the hormone insulin to bring it back down. So if blood glucose is too high, insulin brings it back down. Too high a level of glucose in the blood can lead to cells of the body losing water by osmosis, which can be dangerous. This is very important. So what's the problem with blood glucose being so high? So too high level of glucose in the blood leads the cells to lose water. Losing water is obviously another word for losing water is what? Dehydration, right? Insulin stimulates cells to take in all glucose, so taking glucose from the bloodstream, particularly liver and muscles, which we'll go through in a second. In liver and muscle cells, excess glucose is converted to glycogen, a polymer. So guys, just get this yellow bit down. Thank you for that. So very quickly, we're going to look at the two different types of diabetes. It will cause water levels to be drawn in to the right level, not to the point where it will burst. But remember, yeah, the water loss is the dangerous result. Does that make sense? So your body is trying to not get to that stage. So what it does, it will do homeostasis to bring your blood sugar back up, so it doesn't cause your cells to lose water. Bit random, Zion. Let me know if that makes sense. Guys, I'm moving on. Yeah, I'm moving on. Guys, does the... Oh, last line. Sorry, I'm going back. Probably on Thursday. Ali, probably on Thursday. Yes, correct. Yes, well, correct. Orbison, let me know if that's okay. Anyone else taking notes, let me know. So here's a question, yeah, for the whole group. Here's a question for the whole group, and I want everyone to answer it. Is blood glucose monitored by the pituitary gland? Very good, very good. So what's it monitored? What monitors it? Fantastic, very good. Well done. We have a consensus. It is the pancreas. Very good. Where is the pituitary gland located? I need more than the brain, by the way. Thank you, Mohammed S. That's what we wanted. Thank you, Yasma. I need more than just the brain. Thank you, George. Thank you, Krish. Is that French, Zeus? Or either just crazy spelling errors. Good. Base of the brain. Fantastic. You know what, Nathan? I'm going to fact check that. So leave that with me. I think I need to actually check in on that to make sure before I agree to it or disagree. Okay, so let's talk about diabetes. So very quickly, guys, there's two types of diabetes, type 1 and type 2. Which one is the one that is brought about by lifestyle choices? Which one is the one brought about by lifestyle choices? Yo, I've got the answer on the board. Delete. Okay, there we go. Thank you, Nathan. Thank you, Zeus. Thank you, Seal. Thank you, Krish. Thank you, Zia. Awesome. So it's type 2. Yeah, it's type 2. By the way, yeah, an unethical way to remember it is type 2 is the one that is brought on by having too much sugar or being too lazy. If that helps, then let me know. Type 1 is hereditary. Type 1 diabetes is a disorder in which the pancreas fails to produce sufficient insulin to control blood glucose levels. Scientists think this is a result of a person's own immune system destroying the cells of the pancreas that makes insulin during development. So type 1 diabetes doesn't have anything to do with lifestyle choices. It's everything to do with genetics. It's a disorder. Type 1 diabetes is characterized by uncontrolled high blood glucose levels. Why is it high? Why is it not low blood glucose levels? Why is it just high? Why is it uncontrolled high blood glucose levels? What's not being released to bring it down? What's not being released to bring it down? No, this is type 1. This is type 1. So it's not to do with unhealthy eating habits. Thank you, Nathan. Thank you, Sokmini. Exactly. You have no insulin. So are you breaking down even the low levels of sugar that you have? You're not. So it's just accumulating in your blood. Do you get it? So type 1 diabetes, the insulin, the pancreatic cells that release insulin are not working. Okay, so therefore you have insulin injections. So anyone who has type 1 diabetes would have an insulin injection, and that insulin boost will basically give them the tools to break down the sugar. Type 2 diabetes, the body cells no longer respond to insulin produced by the pancreas. The person still makes insulin, but their cells are resistant to it and don't respond as well as they should. This can also lead to uncontrolled high levels. So basically, in type 2 diabetes, you have insulin resistance. In type 2, your body doesn't really... Yes, you have if you have type 2, you have insulin resistance. That means you are releasing insulin, but you aren't responding to it anymore. Okay, the cells are not responding to it anymore. Does everyone know the difference? Yeah. So type 1, no insulin being produced. Type 2, insulin is being produced, but you're not responding to it. And that's true. Type 2 diabetes can be, to an extent, can be fixed, can be reversed. What sort of lifestyle choices would one have to make in order to reverse? They both do, Ali. They both do. Fantastic. Yep. Regular exercise, low sugar, low carb diet, all these kind of things. So just better eating habits, that kind of thing. Heart surgery. Are you just throwing in random stuff? A carbohydrate controlled diet and exercise regime are common for type 2 diabetes. Obesity is a big risk factor for type 2 diabetes, probably because a person who is obese may consume a high diet in carbohydrates, and overproduction of insulin results in resistance to it developing. So there are some common sort of traits there. Type 1 is genetic, so it's basically there is a fault in the pancreas, so it's something that can't be reversed until further scientific discovery. So guys, which one is most likely associated to do with a fault in the pancreas? Is it type 1 or type 2? A fault within the pancreas. I'll go back, Tarek, bear with me. I'll go back. A fault, guys, in the pancreas. Every single person, all the zombies, all the NPCs, every single person. Get your neighbor involved. Thank you very much. Thank you, Ben. Thank you, Ali. It is type 1. Type 1. And type 2 is the one that's reversible. Which one is most likely for the patient to be taking insulin injections? Thank you, Nathan. It's appreciated. Which one is most likely for injections to be used? An insulin injection. That's right. Thank you, Ali. Thank you, George. It is the type 1 diabetes. Okay. So imagine you have a football player. Peak performance in season. Gets diabetes. Likely to be type 1 or type 2? So imagine you have footballer. Peak performance. Top of his game. Top of his health. What sort of diabetes, if this person develops diabetes, what could they have? Most likely to be type 1. So possibly something hereditary. Because type 2 is to do with lifestyle. Do you guys remember when I said that? Yeah, type 2 is when you're too... I don't like using this example because it's a bit insensitive, but it's when someone has too much sugar in their diet or too unhealthy. Do you see what I'm saying by two? Yeah, I don't want you to forget it. It is, Ali, man. It is. If only if only I could implement that. Yeah. Okay, let's go. What, running in the morning? That is that's some high level stuff, man. Going for. Have you seen how cold outside is? I'm kidding. It's I should make it a goal. No, it's I'm just kidding. It needs to be done. Okay, so type 1, type 2. So what's the cause? Type 1, inability to produce insulin. Type 2, resistance. So you're producing insulin or not enough insulin, and the cells are just not responding to it. Treatment. What's a treatment for type 1? Monitoring blood glucose level, injecting human insulin, particularly after meals. Type 2, maintain a low. So the doctor would say, reduce certain levels, increase your exercise, and reduce your carbohydrate intake. Is everyone good with this? I want to move on to the more stressful parts of this topic. It is, but it's more. See, the thing is, where we are in our scientific, in our science at the moment, is that it can be controlled. So people do live with it for a very, 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 very long time and can live a very normal life. So, so it's science has scientific discovery has led us to improve lifestyle for those who do have type 1. Okay, let's go. So negative feedback. So if the blood glucose concentration is too low, so blood, or should I say sugar too low. Remember what we said, yeah? Sugar too high means cells have too much what? Sugar is high, cells have too much. What do they have too much of? Oh, sorry, too little what? Sorry, I've used the wrong word. Cells have too little what? Water. Very good. Well done for those who remembered it. So when sugar is too high, cells have too little water, because it's not to do with insulin. I'm just saying, if the sugar level is too high, there's too little water. So if sugar is too low, what other problem can come about? Cells have? Good. They have high water content. So in both situations, are cells damaged? Can cells get damaged? Yes. In this way, they can lose their shape. And in this way, they can burst. And therefore, damage. Yeah, you did. Oh, is this what you meant? Sorry, sometimes I'm misunderstanding statements put in the chat. If blood glucose concentration is too low, the pancreas produces the hormone glucagon. Okay, so if blood sugar is too low, the pancreas produces glucagon. If this sentence said, if the blood sugar concentration is too high, what would that word be? That's right, Mohammed S. Yes, that's right. If you can actually overhydrate, it's actually dangerous. So if that word was too high, what would that word be there? So if the blood glucose concentration is too high, do you say how? Because you'll lose all your minerals through osmosis. Okay, so this word will be insulin. Okay, so if blood glucose concentration is too high, too low, sorry, the pancreas produces glucagon. That causes glycogen to be converted into glucose and released into the blood. Glucagon and insulin interact as a part of a negative feedback cycle to control blood glucose. So guys, this is a lot of words, yeah? So let's shrink this a little. We don't want to overburden ourselves here. So why does a person release glucagon? It's because of all their glucose is gone. Get it? No? Too early for these kind of jokes? Okay, let's pretend that never happened. Did everyone hear it though? Tariq, no, it isn't. Okay, so let's break down the statement. Insulin produced when glucose rises. Okay, so glucose or sugar too high. This results in insulin produced We did this about 200 times. Insulin produced. Okay, now insulin being produced tells the liver, okay, and muscles to convert excess sugar into glycogen. Okay, so if all that sugar is being removed, what does that do to the blood sugar level? Oh, that's quite funny, Hassan. So I'll say it again. If glucose is too high, insulin is produced. The liver then converts the excess sugar to glycogen. So what does that do to the overall blood sugar level? Thank you, Mohammed S. Thank you, Zion. Blood sugar is brought down. Thank you, Orbison. So let's think about it on the flip side. Think about all the glucose is gone. All the glucose is gone. So you're very low on blood sugar level. Very low on blood sugar level. Yeah, you just did a marathon, a 15-hour marathon, right? So all your glucose is depleted. So instead of insulin being produced, right, glucagon is produced. Okay, so glucagon is produced when blood glucose level falls too low and stimulates the liver and muscle cells to convert glycogen. So it tells the liver and muscle to... Guys, what do we do? What do we do when I don't know, you're low on resources? You go back to your stockpile, right? You go back to your stockpile. You go to your stash, and that's a nice word. I like that. Chest in Minecraft. Should we leave that in 2025? So yeah. So when glucose is too low, glucagon is produced, and liver muscles. What do they do? They convert glycogen. They convert the storage molecule, glycogen, into glucose. So now we got a bunch of glucose in our body. What happens to the blood sugar level? That's funny, David. What happens to the blood sugar level, guys? Thank you very much. It goes back up. Why do we call it a negative feedback? Why do we call it a negative feedback? Because this whole thing here is about counteracting change. It opposes change, So imagine you do an exam, right? You find out you got a grade U star, yeah? What does negative feedback tell you to do? Sorry, was that traumatic? Sorry, my bad. The bro got a U star. What happened? It tells you to lock in, right? Do you understand? And what happens when you're getting straight 9s and you start to get bored of getting 100%? Start to get a bit relaxed, right? So that's what negative feedback is. Yeah, you get complacent. So it's counteracting the change. Okay, counteracting the change. That's what it is. So what do you think positive feedback is? What do you think positive feedback is? If you know that negative feedback is counteracting the change, what do you think positive feedback is? Yes, encouraging with it, supporting the change. So for example, a person who is, I don't know, addicted to a certain drug, right? Will they end up having more, even though it comes at their own detriment? Good. That's positive feedback, ironically. Does that make sense? So that's the difference. Positive feedback and negative feedback. This is why it's dangerous to have friends who get U stars. Because if you get a U star, they'll be like, yo, bro, you looked it, bro. You smashed it, bro. And then you end up getting another U star. So that's positive feedback. Okay, let's move on. Have we got this all written down? I know. Okay, are we good, people? I'm gonna test you on it right now. I think U star is like basically zero. It's not a thing. I just made up. Right. Okay. Question for the chat. Question for the chat. I'm gonna draw a process. Yeah. So this is a very bad drawing of the liver. What got released to cause this process? Just reading my mind at this point. Unless your internet connection is like extremely fast. Guys, what's going on? What's going on here? The liver is converting glycogen into glucose. Why would this happen? Thank you, Nathan. Thank you, Krish. Let's see what the chat is saying. Thank you, Zion. Well done. Thank you, Adam. Thank you, Aldion. Well done, Mohammed S. Well done, Orbison. Thank you, Hassan. Yep, thank you, Adjo. Awesome. So, guys, why would the body want to start releasing glucose? Because blood sugar was low. So, what got released to tell the liver to do this? All the well, if you need glucose, it's because all the glucose was gone, right? Yo, does that make sense? So if the liver was converting glucose into a storage molecule called glycogen, why would we be storing all this glycogen? Storage molecule. Because there's too much glucose. And what hormone told the liver to do this? Yo, we put the glucose in, so it's insulin. Yeah, that's clever, actually. Yes. No. Glucagon is the first process. So this is insulin. Insulin tells the liver, take the glucose, turn it into glycogen. It's alright, it's alright. Okay. Another question, yeah? Another question. No, the pancreas is what's releasing these two things. The pancreas is the thing that's releasing these two things. Glucagon and insulin. Right, here's a question, guys. Here's a question. Is it just the liver that causes this change of glycogen into glucose or glucose into glycogen? Is it just the liver that does this? No. As in that conversion, that process of conversion, is that only happening in the liver? Okay, hold on. Let's see what the chat is saying. Yasma, well done. Nathan, well done. Remember, the pancreas just releases hormones. The pancreas just releases hormones. Is there another thing, another tissue that does this change? It's the liver and the muscles. Remember that, guys? Liver and muscles. Guys, if you haven't got this written down, can you please get it down? Guys, the response rate is a little bit poor today, but I'm being kind, yeah. From Thursday, I'm getting on your cases, people. Yeah, I'm getting on your cases because we need to do well. I don't want you guys stressing last minute. It's too stressful to stress last minute. Well, you'd think people know, right? You know this is our final term for year 11. If I didn't know, that would be... Guys, 4.5 months, you know? 4.5 months. It's grind season, people. It's a grind season. I call it 5 hour a day season, except for weekends where it's like 9 hours a day. 4.5 months. It's not a long time. Put it this way: your holidays are like 2 months. Thank you, Zainab. We just basically went through some of the liver and how it sort of produces a change. I'm off socials until GCSEs. I'm liking that move. Guys, can we move on? Let me know. Let's do it. Let's do it, guys. We're gonna take a quick break. Yeah. You're done right. Unfortunately, I don't think it. You know what? It's gonna take time for your focus to come back. It's gonna take time. You don't like. It's like a person. If they make a change, they're not gonna get immediate results. It's gonna take a bit of time. It's like when drug addicts get off their drug, they go through a process of real difficulty before they seem to. No, I'm actually not joking. That's actually a really accurate comparison. Guys, we're gonna have a 5 minute break. Yeah. Okay, guys, let me know if you're there. We're back. We're back. Okay, right, let's go. Where did I go? I was giving you guys a break. I'm not gonna talk during a break, guys. That's just beats the point. Right, let's go. We're gonna talk about humans, hormones in human reproduction. Okay, bear with me. Why is this not loading? Okay. So, guys, what sort of hormones would trigger a change in the human body? So, like, for example, someone going through adolescence, turning into an adult, basically. What hormones am I referring to? Fantastic. Good. So you got estrogen and you've got testosterone. So those are the ones I'm referring to. Okay. So puberty. During puberty, reproductive hormones cause secondary sex characteristics to develop. The main male reproductive hormone is testosterone, which is produced by the testes. Testosterone stimulates sperm production. So testosterone comes from the testes. Estrogen comes from the ovaries. And progesterone as well. Estrogen plays an important role in the menstrual cycle, which begins at puberty, as well as causing physical change to occur in the body. During the menstrual cycle, eggs in the ovaries begin to mature and one is released approximately every 28 days. So we're going to go through this process now. Let me pull up the cycle right here. Right, guys, I've seen so many 6 markers on this. Please note it well. Okay, the amount of 6 markers I've seen on this, please just note it well. There's a lot of terminologies that I want you to sort of memorize. So let's go. Let's lock in with this. Okay. What was it recently, Adion? Okay. Hopefully everyone's there. Okay, let's go. Awesome. Right, so during the menstrual cycle, the lining of the uterus builds up and ovulation occurs. Okay, so during the menstrual cycle, the lining of the uterus builds up and ovulation occurs. I'll show you a diagram in a second. So the average menstrual cycle takes 28 days. The average menstrual cycle is 28 days long, and there are 4 overall stages. So let's look at the 4 stages. The first one is menstruation. So this is the loss of the lining. So imagine you've got flesh, and that flesh needs to be regenerated. It needs to be constantly regenerated, and that regeneration takes place over a 28-day cycle. Okay, are you guys following? Yeah. So this tissue needs to be regenerated. Okay, so this is what we're talking about. And hormones control how that process takes place. Okay, do you get it? So hormones basically are like almost like time checkpoints at which change occurs. Okay, so the first part, yeah, we're getting into it. So the first part, we're talking about stage 1, the loss of the lining from the uterus. So if we look at the uterus, I'll draw a triangle sort of to oversimplify the diagram. So this is the uterus. What you have is you have this lining here. Okay, you have this lining here. So whatever's within the uterus is essentially protected, growing, whatever, right? So here you have the lining of the uterus. The loss of the lining of the uterus occurs from the start of the cycle if no fertilization has occurred. Very quickly, guys, if you remember from Unit 1, what is, or maybe not even Unit 1, maybe Year 8, what is fertilization? Fertilization is the formation of what? Begins with a Z. Formation of a zygote. Very good. Okay, what is a zygote? A zygote essentially a sperm cell and an egg cell that have fused. Okay, that's what fertilization is. So if there's no fused cell, right? If there's no and by the way, this zygote, which is the fused cell, will go on to become a baby, right? So if there's no fused cell, the cycle will repeat itself and regeneration will happen again. Are you guys following? Yeah. However, if there is a baby, there's not going to be a regeneration. Now, the sort of the environment for the baby is then altered for that baby to thrive. Okay, so I hope you understand the context that we're talking about, because there's no diagram here, it's just words. The lining, so first one, the lining breaks down. That's the beginning of menstruation. And why does that happen? If there's no fertilization that's taking place. 2, the lining starts to thicken up, so it builds up again, and then you've got ovulation. So ovulation occurs around the middle of the cycle, so at 14. An egg travels down the oviduct. Anyone know the other name for oviduct while we're on this topic? Anyone know the other name for an oviduct? Thank you, Hassan. Thank you, Krish. Thank you, Nathan. Thank you, Adam. Anyone heard of the fallopian tube? To be fair, I think I'm spelling this wrong. Awesome. Okay, thank you guys. Yeah, so it's the fallopian tube. Yeah, so the egg is released around day 14. This is this production of the egg is, or the releasing of the egg is ovulation, and then the lining is maintained. It stays consistent, ready to accept a fertilized egg. Now, if that fertilized egg isn't present, is that lining maintained? If the fertilized egg is not present, is that lining maintained? Fantastic. The answer is no. And then what happens? We go back to step 1. Is that okay, guys? So this process, this cycle, takes how long? Fantastic. Yeah. The process takes 28 days. Okay. What a tangent. What a tangent. Oh, wrong thing. Let's get a new page. Right, here we go. So this is what I'm talking about. You know that triangle I drew? You know that triangle I drew? That is, imagine that's the triangle. There, that's the lining. That's a flop drawing. Basically, the inside of the triangle is this. So it should have been like that, basically. Does that make sense? So there's a lining this side, there's a lining this side. Okay, that makes up the uterus. So you got the uterus lining. So it starts here. And can you see that first stage that the lining is broken down? So let's just, for example, let's give this a measurement of, I don't know, 10 centimeters. It's not 10 centimeters, I made that up. And then that would be like 2 centimeters. So can you see in the first section of menstruation is where that lining is being broken down. Okay, that we call that process menstruation. Yeah, correct. Day 14, what happens? After that, from day 7 to day 14, the lining is being built up again. And then day 14, what happens? Ovulation. What did we say ovulation is? So basically, ovulation is when the releasing of an egg, right? So menstruation, the lining is broken down. After that, the lining is going back up. It's starting to be rebuilt. And then an egg is released. Okay? Oh. Okay. And then why would the wall break down again? Why would the wall break down again? So we've gone past 28 days. Why would the wall break down again? Yeah, but why? What's allowing that cycle to repeat itself? Thank you guys. Thank you. Anyone else know? I'm opening up to the chat. I'm not going to go fast with this one. Why is this process happening again? Why did it not maintain? Thank you guys. By the way, some people put the right answer and I don't want to say just yet. I'm waiting for a few more. Fantastic, fantastic. Okay, so the reason why this wall is breaking down again is because no egg was fertilized. So therefore, that's fine, Zia. This process repeats itself. Have you not noticed this part of the graph is the same as this part of the graph? They're identical. Okay, so that process repeats itself, and it would have maintained if the egg was, no, this is everyone, was fertilized. Okay, let's move on. Okay, hormones control of the cycle. I'm recording lesson, by the way, so that's fine. This 4 hormones control the events that occur during the menstrual cycle. 2 of these hormones, thank you so much, of these hormones are produced by the pituitary gland. So the master gland is controlling this whole thing. Okay, we said that progesterone and estrogen are from where? Good. Released by the... Good. Which one though? Which one? So it's released by the ovaries. Okay. Whereas these other hormones, what we're going to talk about in a second, so it says 2 of these hormones are produced in the pituitary gland, which is in the base of the brain. So follicle stimulating hormone, FSH, causes the maturation of the egg. And luteinizing hormone, which stimulates the release of the egg. We're going to get to the corpus luteum and all that stuff in a minute. I've got another diagram. So follicle stimulating hormone causes maturation of the egg. Luteinizing hormone stimulates the release of the egg. So which one do you think is literally happening on just before day 14? Which hormone do you think is being released just before day 14? Thank you, guys. So remember, we're talking about the hormone that releases the egg, not the maturation. Maturation means that the egg is getting bigger and like ready to be released. But that actually happens on day 14, where the egg is sent out. There's going to be LH, right? Would you agree with that? Awesome. The other 2 hormones, estrogen and progesterone, are involved in maintaining the lining of maintaining the uterus lining, with estrogen being made by the ovaries and progesterone specifically by an empty egg cell called the corpus luteum. Okay, so the corpus luteum. Oh, I understand your question now. Sorry, yeah, you're right. I understand what you're saying. I'm gonna take that off. That's the scientific inaccuracy. Yes, it is the corpus luteum. Well done. So thank you for pointing that out, Adyan. Guys, can you get some of that information written down? So just remembering that the FSH and LH is from the pituitary gland, and estrogen is from the ovaries, and progesterone is from the... Whoa, what happened there? And progesterone is from the corpus luteum. That's right, Ali, that's correct. So the whole timing of the process is triggered by the pituitary gland. Wait, what do you mean? When you say it's? What are you referring to? When you say it's, what are you referring to? No. As in you said. So is it controlled by the? What do you mean by it? Do you mean the lining of the uterus? That would be the ovaries. Yeah, I would say so, Zion. Yeah, I would say pituitary gland. Pituitary gland, because it's the pituitary gland that controls the ovaries, right? Guys, do let me know once you got this written down. And what I'm going to do, I'm going to run through the process, and then I'm going to run through it again in the beginning of the next lesson. Is everyone okay with that? So I'm going to run through this whole cycle now, and then I'm going to run through it again at the beginning of the next lesson. CL stands for corpus luteum. And you're going to find out now what that even is. So let's have a quick look at this cycle. Okay. Guys, with next lesson, can you please get into the mindset of responding? If you can't respond, log in on another device using the same code, and it will be... I'm talking for those who have not responded all lesson. Can you please log in on another device and respond that way, if it's easier? Okay. Yeah, of course, I'm not talking to you. Okay, so the pituitary gland produces... Hold on. I'm talking to people who haven't responded. You have responded, so I'm not talking to you. Okay, chillax. The pituitary gland produces FSH. So there's the answer to your question, Ali. So the pituitary gland produces FSH, which stimulates the development of a follicle in the ovary. Remember, it's the follicle stimulating hormone. No, not the same as a hair follicle. So the pituitary gland produces FSH, which stimulates the development of a follicle in the ovary. An egg matures inside the follicle, and the follicle produces the hormone estrogen. So an egg matures inside the follicle, and the follicle produces the hormone estrogen. So FSH stimulates the production of estrogen. Is everyone following the flowchart? Yeah, is everyone following the flowchart? So FSH releases the triggers the release of estrogen. So just to kind of remind you of what I'm saying, right? First, you have the pituitary gland. Pituitary gland produces FSH. That produces a follicle, and then an egg starts to form inside the follicle, and then the follicle produces estrogen. Okay, so I think there's a few more steps we can add to this flowchart. So you got the pituitary gland releases FSH, and then the FSH releases an egg or follicle, and the follicle produces an egg, and the follicle also produces estrogen. Yeah, exactly. Yeah, it's all to do with this. It's all to do with this. There's a couple of different loops in here. Okay, are we good on this flow chart here, guys? So pituitary gland releases FSH. The FSH releases follicle. The follicle produces an egg. The follicle also produces estrogen. Are we good, guys? Let me know. Adam, man, do we still have you? Let me know. Zion, you still there? Zion, man, what's up? Oh, right, okay. Thank you, Adam. George, we there? Kiwi, Annie? Right, let's go. Awesome, awesome. We're there. Okay. Right, estrogen causes growth and repair of the lining of the uterus. Okay? Estrogen causes growth and repair. Now, I want you to just imagine, do you remember that cycle that we had before? We had 0 days, 7 days, we had 14 days, we had 28 days. So just remember the cycle, right? And if you remember the diagram, it was like the first part of menstruation is where the wall is breaking down. Right, you remember that bit, guys? The wall is breaking down. And then it starts to slowly build back up. Right? So if you remember, when do you think estrogen is produced? Because we know estrogen causes the growth and repair. So have a prediction. Where do you think this estrogen is produced? What day? Day 0, day 7, day 14? Just make a prediction. We know what the estrogen does. It causes the growth and repair of the lining. So first, from day 0 to day 7, lining is broken down. Day 7 to 14, lining is being built back up. So I would say day 7. I would say day 7 because the lining is being built back up. 14 is when the egg is produced. You guys remember that? So estrogen causes, so what is estrogen? Let's go back to the flow chart. So estrogen causes lining to be built. Okay. And inhibits the production of FSH. So FSH's story has now come to an end. Okay, so now that the wall has been built up, FSH is no more. Are we good so far, people? And that is a negative feedback loop, correct? Okay, awesome. So just to kind of remind you, pituitary gland first releases FSH. FSH releases a follicle. Follicle releases two things, an egg and also releases estrogen. Estrogen causes the wall to be built up. Now that the wall is built up, FSH is no more. Okay, because if you got more FSH, that means you got more egg. And do you want another egg? It's always one, right? And also, do you want more wall to be built up? No, right? It can't. It gets to it's got to stop at a particular level. Okay, so we've done up to here. The follicle becomes a corpus luteum. Okay, so now the follicle has now become a corpus luteum. And the corpus luteum produces progesterone. I'm going to stop right there, guys. Progesterone. Spelling is crazy. I'm going to stop right there. Who has got that flow chart written down? I zoned out for a second. And do you... Oh, basically, the FSH really causes triggers the release of an egg, right? So if you have more FSH continuously, you're just going to get loads of eggs being produced. Does that make sense? And of course, that will cause multiple births. Yeah. No worries at all. Guys, can I ask one question before we finish up here? Yes, exactly. And we don't want that. We don't want that. So knowledge of all these hormones, right? I just want to ask one question. We're done. They're not supposed to be majority. They're not supposed to be majority. That's the thing. That's what it is. Because there was a lot of strain, right? Right. Okay. So let me ask you guys a question. One last question before we go. Yeah. Has everyone by the way got that flow chart written down up to progesterone? That's the first thing. Awesome. Most people have said yes. Okay. So here's my question. Right. I'm not testing your knowledge. I'm just going to ask you a question. So if you look at this flow chart, let's say you now have this newfound knowledge of hormones, right? And how hormones affect a female's ability to have a child. Okay, so now you have that knowledge of the hormones, and you understand that this cycle here affects the ability of a female to have a child. So you are now trying to be a good scientist, right? And you want to play with the levels of the hormones in this cycle. What could you do to help? What hormone could you adjust, or what hormone could you promote in order to maybe increase the chances of a child being sort of birthed? What hormone would you increase? Yes, I'm speaking. Yeah. Yes, I am speaking. If you want me to ask the question again, I can. And it's the last question. I'm gonna stop after this. So imagine you now have understanding of the hormones. Okay, it's the 19 whatever, right? You've now got understanding of the hormone. Is my sound gone? Oh no, is it actually? Guys, can you hear me? Yo, I can't lie. I think I just ended up. Does that sound like I was in a tunnel? Yeah, I'm back. I don't know. Is it any better now? It's echoing. Is it still echoing? I know, Ali. I know. Okay, it's not. It's not. Okay. Okay. Right. It sounds like I'm underwater. Is that how bad it was? Oh man. Right. Okay. Hopefully I'm back. I've just got one question and I'm done. Just got one question. Okay. So I'm gonna say it one more time. You've got this newfound knowledge of the hormones, right? You're trying to help a person have a child. What hormone would you adjust? And give me a reason. What hormone might you adjust? What hormone might you promote? And is there a reason as to why you promoted that particular hormone? All of them. Okay, that's an interesting suggestion. If you increase all of them, then won't that cause the lining to be maintained? Actually, that's a good point you've made. So some people are saying FSH, and I would agree because FSH. No, you were right when you were kind of right when you said all of them. But I would definitely say FSH because you want the egg to be produced, definitely. You also want the lining to be kept. I'm intrigued about progesterone. Some people say progesterone. I'm intrigued about that. No, we're talking about particularly in this cycle. Particularly in this cycle, the pituitary gland is the master controller. So you might produce a hormone to what cause to increase pituitary gland activity. Is that what you're saying? I think that's not a bad idea actually. LH releases more eggs. Hmm. Hmm. Yeah, I think LH as well. Guys, I'm going to stop talking. I think that was quite an interesting one to think about. You could have some health risks. Yeah, you could have too many births. Do you know when people have in vitro, there's a chance of multiple births. So that's quite common for triplets and quadruplets and stuff. Okay, guys, yeah, very interesting discussion there. So I would say, in fact, a lot of those hormones will be increased. Um, Let me know in the chat if you learned something new today. I hope you have. We covered quite a bit. We went through the menstrual cycle. We went through part of the menstrual cycle, not all of the menstrual cycle. We went through the menstruation. We went through negative feedback with the blood glucose level, type 1, type 2 diabetes. We went through the different types of endocrines. Is that a word? The different types of glands in the endocrine system. Went through quite a bit here, so that's great. Awesome. Thank you very much. Guys, enjoy your evening, people. Guys, we are going to lock in on Friday and Thursday. Can we please come with the right work ethic, yeah? I'm not I'm just trying to be extra here, but can we just come in with that with the locked in mindset? Because we're going to be going on super exam mode. Right, let's go. Thank you very much, George. Thank you, Ardian. Guys, enjoy your evening, people. See you soon. Have a good first week back. Awesome, that's good, Ali, and awesome, a good step for the new lesson. Thank you, Kivi. Thank you, Sia. Thank you very much. Thank you, Krish. You too, Ariane. Thank you very much. See you soon, people. Thank you, Tarek. Take care, people. Thank you, Hassan. Thank you, Orbison. Thank you, Zion. I need to practice physics equations. When is your physics test, though? Because I'm gonna go on. I'm gonna do a physics lesson. On a 6 p.m. session, so I can tell you when that is so you can brush up on it. Thank you, Orbison. Thank you very much. No, it ended. Oh, really? Can you send me a copy of the paper? That might actually be helpful. just so I can see like what you mean by badly and where you went wrong. But you're the only one kind of in the lesson now. Sure, they were all 6 markers, 4 markers, and 6. They're the worst, aren't they? They are the worst. Because when you get them wrong, it's like you're losing out too much. Don't worry, we're gonna be. By the way, this is totally up to you, yeah, because only you can sort of decide whether it's too much or not. But because the exams are so soon, and because you kind of missed out on some time, I'm more than happy for you to join at 6. And some of the GCSE students do join at that time. I've made it sort of an open rule for anyone. You can join at 6 and catch up on missed knowledge. So if you're going to be studying anyway at home, you can just log in at 6 o'clock and have an extra hour, and there's no extra payment for that. So we only got 4.5 months left to try and make the most of it, because I'm going through a lot of Unit 1 stuff, and a lot of the equations you're talking about is in P1. So that's all the gravitational potential energies, elastic potential energies. So you are welcome to join it. It's your choice. You know how intense that can be. How about you join in and then just like sort of join in around like 6:15 or maybe 6:30 even. So, but yeah, there's that option. At least on Friday, at least on Sundays, right? At least on Sundays, because Sundays is just science. Cool. All right. Thank you very much, Mohammed S. I'll catch you soon. Good stuff. Well done for participating as much as possible. I can see the work ethic there is good. It's good work. Thank you very much. Thank you. See you soon.